everybody that's attending, thank you for taking the time out of your day to listen to us guys talk about laser scanning. Mark already introduced me. My name is Chad Long. Like you said, I'm a BIM and 3D laser scanning specialist here with GeoShack. I've got 10 years of experience in land surveying, and now I've been with GeoShack coming up on 2 years, and love it. Like I said, great company, great product. We're proud to show you guys. So real quickly, I'll do just a couple of slides on Topcon. That is our manufacturer. Introduce you guys to GeoShack. We'll cover just a little bit of laser scanning 101, and then I'll introduce you to the Topcon GLS 2000. So not to delay, Topcon, you might have heard of them. They were established in 1932 in Tokyo as an optical instrument company. They since then, came stateside in the 70s where Topcon America was formed, and they're still based over in California today. Some of the things that you might see Topcon positioning-wise, today we're talking about laser scanning. That's just one of their business units. They specialize, GPS, machine control, lots of different things, lots of different products for lots of different applications. If anybody has any questions about that, we'd be happy to answer them afterwards. Really quickly, so talked a little bit about Topcon. So GeoShack is the world's largest Topcon dealer. We service many different markets, many different segments. So here today we're talking about BIM and MEP construction, but if anybody else has any questions, maybe underground, dozers, something like that, we'd be happy to talk with you guys offline. Really quickly, I've got here, I don't know, like I said, where everybody is based out of, but here's a picture of GeoShack's actual footprint. These locations represent brick and mortar stores. So we have, construction supplies, things at these locations, as well as, all of our outside sales reps that support those markets. So GeoShack, is very equipped, to handle a lot of different companies, a lot of different workflows. Really quickly, so there's two different types of laser scanners, and you guys will probably hear about them, the more you do a little bit of research into them. But the Topcon GLS is actually a time-of-flight scanner. So whenever the EDM on the scanner releases its pulse, it actually starts a timer, and it's measured until that pulse is returned. So calculating that time, they're able to take it through a few formulas really quickly, time of flight, and then actually calculate that distance. So on top of capturing the distance, it's also measuring a horizontal angle, vertical angle, intensity, and a color value. So we're capturing all those things while we're laser scanning with a time of flight scanner. The other one that you might hear of is going to be a pulse laser scanner. So what those are is basically it's a sine wave that is emitted from the scanner. Whenever it leaves the scanner, it's recorded. Whenever it bounces off the object, it is changed, and then that sine wave is then measured, when it is received again. The difference in those two sine waves is known as a phase shift. And so whenever they calculate that phase shift, that's how the phase-based scanners are able to calculate their distance. Very long algorithm, but kind of what I wanted you guys to see in having these two slides and explaining the differences is the time of flight scanners are going to give you considerably more accurate data just by the simple formula that it uses, to calculate its distance versus the algorithm, the phase-based laser scanners. Some common terms that you guys hear, I'm sure you've already all heard them, but raw scan data is coming out of the laser scanner, point clouds, registration. So whenever we have scan positions, multiple scan positions, we'll register them, eventually export one point cloud, and then turn that over, to you guys in the office to mine or send it over to run through a program such as ClearEdge, to do some automation, some modeling automation, lots of different great features. They've got what they call, and then also too, so the GLS 2000 is Topcon's third generation laser scanner. They have had two previous models. They were great at the time, but now they're a little bit obsolete. So they've rolled different types of technology into this product. Right now, like I said, the Scan Technology 2 is where they were. The Scan Technology Precise Scan Technology actually came out on the first gen scanner, but then they were able to, tighten it up and clean it up, in the latest release. some of the key features about the GLS 2000, we've got selectable lasers. So if you're working somewhere where you need an invisible laser, that is definitely an option. We've got, the full dome view, 360 on the horizontal and 270 on the vertical, and several different modes too that we can choose from. We actually have on here the GLS 2000M, which is a 350 meter. It also comes in 130 meter, and it also has a 500 meter range. So there are different applications, where we would use these different scanners. We'll be happy, to answer any questions about that as well. The only scanner on the market that you're going to see with an occupation and backsite option is the Topcon GLS 2000. And what that means is we're able to set this scanner up in the field over some control points, and then right then and there, our scan is geo-referenced to our model coordinates. The only scanner that can do that. A couple of other features. We've got easy operation down here. You guys can see a screenshot of the actual scanner. So everything is good. All we have to do is just hit start scan. So it's very easy to actually do the scanning process. So once we are done scanning, we would then export our raw data via an SD card onto our PC, bring it into a proprietary software of Topcon called ScanMaster. ScanMaster, they're also in their third release of the software. It's a very strong point cloud processing software. It has a lot of automated extraction, like edge extractions. We can create meshes, lots of different details, that I can go into. So if anybody has any questions of what we can do inside of ScanMaster, please, let me know. I mentioned, the occupation backsite routine to register your scans. There are actually two other ways to register scans. So if we don't have control points, we can actually go out there, set up our scanner, and still collect accurate data. We can use targets. We can do cloud to cloud. And my preferred method is go out, occupy a backsite so that we are geo-referenced, and then basically cloud to cloud register all of the other scans to that geo-referenced scan, the initial scan. So it makes it for a great workflow, very fast. First-hand knowledge, so if any of you decide to actually do work with GeoShack, we've got, great staff. Our trainers are excellent. Tons of knowledge still in laser scanning. We've been doing it for a really long time, and we have a lot of knowledge and a lot of expertise, to pass on to our customers. And really quickly, I've got on here just a success story of a couple of guys using it, but in this model, everybody can see in there that they've got a lot of mechanical systems going on. So this is actually a hospital that's being built right now, where we're actually going in there and using another one of ClearEdge's programs. They'll probably talk to you about, but to compare, our model data with what we're scanning. So, Mark, that's all I've got, on the GeoShack. Like I said, if anybody has any questions, please type them in, and we'll go from there.
Great. Thanks, Chad. So I'll go ahead and take control back. All right, guys, so next I want to show you, do kind of a live presentation or example here of the control points and how important that is with working with scans and inside of Revit. Before I do that, first thing I would highly recommend, and whenever you're working with point clouds, a product available through Autodesk is a product called Recap. The Recap 360 Pro does give you the ability that when you receive multiple scans, you can register them or stitch them together to form one large scan of your model. And that's possible with scans from any point cloud. However, if we use the points that we receive from the Topcon data, they have coordinates assigned to them. So most of the time when we bring those scans in, if they're using control points, they come in and they align perfectly right off the bat. In this example, this is showing you what the scan looks like inside a Recap. I highly recommend that no matter what scan you receive from any scanner out there, you bring it into Recap first. Once you bring it into Recap, then you want to go through the process of exporting out those files. And you export it out as a RCP or RCS file. that will take that point cloud, which can be a very large file, and it will reduce the size considerably. Now, while you can bring point cloud data directly into CAD and Revit and Navisworks, if you go through recap first and then save it as a RCP or RCS file, when it comes in, the file size will be reduced, and CAD, Revit, Navisworks does not have to take the time to process it. It all happens automatically. So it's already been processed here inside of recap. So now this is the model inside of recap. This is a mechanical room, and I can do things like fly through the model, and I have some other functions. Unfortunately, this scan, it's a rather clean scan on the outside. I'm going to show you another scan that I can demonstrate some features and functions that I've preset. So here's a mechanical room. I can set it up where I can view from the point of view of the scanner, so to look like an image. But notice the points here, and right here on the left-hand side, you can see all the individual points. They have a color assigned to them, so it looks like an image. And then with that image, I can make out what the equipment is, the piping, the walls, the windows, mechanicals, whatever it is that scan has captured. What I'm going to do to demonstrate another workflow is I'm just going to show you this scan right here. And I'm going to save that real quick. And I did this scan because this scan demonstrates, and this actually we did live. Chad and I did this live, gosh, more than a year ago in Kansas City, and he actually set up a scanner inside this room, and it actually shot through the windows, and so it was picking up points outside our room. So here's a good example for using recap to filter out some of the data. I don't want to spend too much time in training mode here, but just to show you, if I go to my limit box here, that I have the ability that I can filter out some of the data. You'll notice that my scan data and this box are not positioned the same way, so I can take this by simply clicking on the edge, and I can rotate it. And you'll notice right down at the bottom it says click to edit this box, tab to edit the dimensions, or hold control and click on an edge to rotate the box. So that's what I'm going to do. I'll take this, I'll rotate it, and I'll get it lined up, and then from there I can filter out some of my data. And I'll go ahead and confirm. So I always tell people, do whatever cleanup you can do inside a recap first, then export this data out, and you can bring it directly inside of Revit or CAD. Now, just to show you some points of view here, here's what it looks like inside. This is the level of detail that you can receive. So, if I had mechanical systems overhead, I could actually look overhead and I'll see if the ceiling's not there. I can record that. But I do know where at least my diffusers are. And when I created an as-built model of this room, I needed to locate those diffusers. I assumed all these diffusers were 2x2. And actually, there's one of the diffusers in here that's a different size. And I realized that when I had started modeling that the diffuser that was right above this window was actually not 2x2. It was actually smaller. It was 18x18. And so this is the diffuser right there. So it is a little bit smaller, but during field verification or field measuring, I may not have noticed that, which is a simple tape measure, but with the scan, I was able to see that and measure it. Now, that is using recap, and just to demonstrate now the control points and the purpose of the control points, and especially in the MEP world, if you need to tie into existing systems, you want to know precisely where they are. Well, again, this project we did live, and in this case, I did have these control points. These do have an XYZ coordinate system assigned to them. So with these control points, I gave these to Chad. He entered them into a scanner, and so when I brought the scan into my project, it came in precisely. Now, just to demonstrate that, this is what happens with just about all the scanners out there. And I'm going to do one thing here. I'm going to go ahead and set up my location here because I do have 3D scan control, so I have a coordinate system set up. With any other scan that you bring in, if I was to insert that scan, here's my point cloud, and I'll bring it in one of three ways. I'll first do center to center, and this is very typical. When I do this, notice the scan is just kind of hovering over here in space. Well, that's not going to work for me. So if I do this again, and I select that same scan, this time center to center, I'll do origin to origin, and I hit open. It's closer, but it's still not rotated properly, and I would, again, manually have to slide that around. And I would rather have this scan come in precisely where it needs to. So instead, I'm going to take advantage of the control points that I provided to Chad to put in a scanner. So I'll select my T room. I'm going to use my coordinate system, and when I click open, the scan pops up exactly where it needs to pop up. So in that way, I know precisely. So for my MEP system, my piping, my ductwork, even structural steel, if I need it to line up with an existing model, there's no better way to do that than with control points. And just to show you some of the things that we can do inside of, once we get into CAD or Revit, I can start tracing over it and modeling it. Now, in this example, though, I had to manually trace over my scan. And with walls and doors and windows, that's pretty easy. But with MEP systems, a lot of piping, a lot of ductwork, even with structural systems, it could be tedious and time-consuming. So a better way to do that before I bring in a scan into my Revit model is to use a product like ClearEdge 3D and their Edgewise tool. With that, that'll automatically convert it into some model data, and that's what I'll let ClearEdge demonstrate for you. But for those of you who want to see the need for using control points with scan data inside of my Revit model, this is why we work with control points. So I'm going to turn this over to Justin, and Justin is with ClearEdge, and Justin just made you presenter. Did that pop up?
Yes, I did see that, so I'm going to go ahead and share my screen here. Okay, so can everyone see my screen?
Not yet. Oh, there we go.
Okay, cool. Okay, so thank you very much for the presentation and the pass-off. So I'm going to bring this up really quickly. Okay, so I'm Justin Domer. I'm with ClearEdge 3D. I'm one of the tech support and just people who work with customers throughout the process of learning and teaching, as well as testing the data. And so I'm with ClearEdge 3D here. So ClearEdge 3D, we launched in 2011, and the idea behind it is to automate the process of actually extracting objects, 3D objects from the point cloud data. So right now we are on 5.02, so all the way back from 1.0. So we've definitely done a lot to kind of improve Edgewise. We're constantly working on adding new features and functionality. Currently, we're able to do piping, ducting, structure, and building, just kind of more over MEP products. And so we're able to do that through Edgewise and then export them out to various software. Some of the most interesting things we'll take a look at is the actual QA tools. So the QA tools we have are able to give us a really in-depth view into how the objects we're creating in 3D are aligning with the point cloud. And so that's something that's not very easy to do, and so we are able to do that very well. And then some of the various software we can actually export out to our Revit, which is what we're going to go into today, Plant 3D, PDMS, CADWorks, AutoCAD, and a couple other different ones. So we have a lot of options that we can go through, as well as importing a lot of different scan data. So we have definitely a lot of options in that respect. And then, based on the scan information, we can reduce the modeling time significantly, up to 50 to 75%. I've seen more in the with different models. So it depends a lot on the scan data, but we can do a lot of work very quickly without having to use man hours, which is definitely a big advantage. So with that, I think I'm going to just go ahead and jump directly into the, kind of a live demo. And so with this demo, I can kind of show some of the different tools that we're going to be, using and actually working with. So what we can see here on the screen is an industrial plant that we work with. So this industrial plant is a product. The scan itself is from about 22 scans, so it's not very large, and it took about an hour and a half to process. And so with that processing, we actually are able to extract all these objects automatically. And we can see that we have a lot of stuff extracted just through computer time. So with the computer time, in that hour and a half on just a standard computer, we're able to go and extract these cylinders from the point cloud. And so this is actually square one. This is where we're going to start from and work our way out of. So this is a lot of where the time saving is going to come from, is the fact that we can automatically find a significant number of actual pipes without having to do any man hours. So this is just purely, I ran it, went to lunch, had a meeting, came back, and you can even work on the computer while it's running in the background. So definitely a significant portion of the time saving. And so this is where we're going to start from and work our way to our final product. So with the final product, the first thing we're going to be doing is our QA process. So those QA tools we mentioned before, the most important one of many that we have is going to use our smart sheet here, and this tool allows us to actually look at the individual pipes and then how the point cloud actually lines up with those pipes. So what we can see here, this is a bore shot of this cylinder, so if I move around I can see, and these are all the points associated with this cylinder's extraction. So we see that information, we can see the quality, and then based on that fit, based on the fit of the curve, and the points, we can determine if this is accurate. So we can literally tab through very quickly and see if it's right. If it's not correct, we can delete it, or we are actually able to adjust the diameter as well. So we can adjust the diameter on the fly and make sure that we have a good fit. So this is one of the most important tools for QA that we have. And so this allows us to go through that process and very accurately determine that things are fitting to the point cloud properly. Now, the nice thing about this is we don't have to look at every single pipe that's created. When we actually do this automated extraction process, there can be thousands of pipes that are extracted, which is great, but we can actually narrow it down to the ones we really need to look at. And that specifically is talking about coverage. If I actually look at this, I am not really concerned about looking at cylinders that have 80 to 90% coverage. That's something I don't really need to look at, so I'm going to look at the lower coverage elements to really determine what needs to be done. So this is the QA, and that's just a very powerful tool that we can work with to make sure that everything that's automatically done is accurate. Now that we've gone and QA the process, we need to start making connections. And so that process is done both manually and automatically. So we have these gaps that we need to fill, and so I'm going to just go ahead and run our automated tool here. And so this Easy Connect tool, this is going to go through and make connections, both elbows and straight connectors, and this is going to go through and do as much as it can automatically. So with this, we see that we filled in a significant portion of the kind of main chain runs of piping here. We've filled in a lot of that, as well as some of these different sections. So anything that wasn't automatically done, we would go through and manually do, and so we can actually do that process very quickly. It's literally connecting the dots. So it's a very quick process, very simple, and then also we can extract objects if we need to. But that's kind of the main function and the main tools we're going to be using for filling in connections. And as we can see, we've done done most of it, and so with that process being completed, now we can actually clean everything up. And so this process is just going to finalize the connections. It's going to replace all these black pieces with actual pieces of pipe and kind of give us the final information. And this also, this tool, the whole point of this is to give us as-built conditions. And so we maintain these as-built conditions to show that there is deviations in the pipe. So if we actually look at one of these pipes here, this is a good example of a straight pipe that's not actually straight. And so if we take a look here at the point cloud and kind of see the point cloud, see how the pipe is actually running, we see that it is not a straight connector or straight run of piping, but we're representing that accurately with the software. So we've actually managed to do that. So it's the best of both worlds. Now that we've actually filled everything in, we can add our intelligence. So we've kind of finalized the connections. At this point, what I'm going to do is give us intelligence. So right now, we haven't done that. These are just raw values from the point cloud when we extracted these objects. So what I'm going to do is I'm actually going to apply our intelligence to the model. So that's done with our applying option. So we can do this on an individual basis, on a group basis, but as a time-saving function, I'm going to go ahead and just run this. We see that we have specs from around the world. It's also very easy to create your own. These are literally just spreadsheets that you can import and export and edit, and then different pressure ratings from those same specs. And so I'm going to run this. Visually, nothing's changed, but if we look back at the same view, we can see now that it has our intelligent values. So we can see that these have been changed. We have our actual nominal diameters. We have the intelligence for the full product. Some other things we can do, especially going into Revit, as an example, is I can actually sort by diameter. And what I can do with this is I can actually I'm going to grab everything under 2 inches, and I'm going to change, instead of exporting as pipe families into Revit, I'm going to export them as conduit families. So I'm going to export them as conduit families here. So at this point, I'm going to export and go ahead and export. So we can do that for ducting as well. And that pretty much takes care of all the tools that we have for Edgewise to actually go into Revit. So at this point, I'm going to go ahead and export out to Revit. And it's a direct handoff inside of Revit. So I have Revit already open. It's a systems template. So Edgewise default has the systems template, and then there's a plugin. And I'm literally going to just hit open model and select the file that we just created. So this is going to go through and create those elements as native objects inside of Revit. While this is thinking, I'm going to go back to Edgewise, and I'm going to talk about some structural elements. Now, in this model, we also have some structure that we can look at. So the structural elements, we can talk about actually modeling the supports that hold up the piping that we just actually created. So I'm going to go ahead and hide the piping and bring in some elements that I've already created. So these elements right here are some stuff that I've already extracted. With structure, we have a couple of different ways. It's a little bit more hands-on because we need to tell the software a little bit more information about the type of element we're going to create. But in this case, I'm going to make some I-beams. So I have a steel standard here, but we have various ones. I have I-beams. I'm going to create an I-beam, and I'm going to say auto-fit, which is going to say look for all the different types of auto-beams that we can create. And I'm going to go ahead and extract them from the point cloud. So I'm literally just drawing a box around the points, and this is the same for piping as well. And then once I've extracted that, I can actually look at that element that we see in green here and see the points, how they line up. So I can actually move this object around, and I can adjust it. I can move it around this way. I can resize it so I can create a new element. And then we also see that its role is going to be a beam inside of Revit. So we're actually going to be bringing that into Revit as a proper family. So with that, this one looks good. I'm going to do the one right above it and do the same thing. And the nice thing about this is that I could go through, based on the points, that looks pretty good. I think it's about as good as I'm going to get it there. The nice thing about this is I'm also able to extend these. Now, with this modeling section, I see that I can do this, I could go one at a time for the rest of this, and I could go one for each element, just extract each one individually. But we also have a tool now that allows us to recognize patterns in structure and take advantage of those patterns. And so that's done with our pattern extract tool. And the idea is we create these initial elements, and I'm literally going to say, look for these initial elements. I'm going to define a distance and a spacing to look for, and it's going to go through and try and extract all these objects as fast as it can. So it's going to go through and try and find these elements from the point cloud and extract them. If it doesn't have points to do that, then it won't extract them. And there is a tolerance for finding these objects as well. So while this is going through, I'm actually going to go back to Revit, and we can take a look. So we see that we've created our piping. So all of our pipes and elbows have come in, and all of our conduit elements have come in, and we can actually take a look at this right now. So I'm going to go to a 3D view. And so with these elements in, we can see that they've been created as native objects. So I can select an object. I see that they are standard pipe family. I can see that I can collect on a conduit, and these come in as conduit family objects. So this is bringing in these elements in as native objects, just like they would be created inside of Revit if they weren't, if we'd done this by hand. So it's a very quick process, very powerful tools, and very accurate. Now, I'm going to go back to Edgewise, and so inside of Edgewise, we've finished our pattern extract, and we can see that we've actually managed to extract all of these objects now based on the pattern extract, and it stopped where it needed to because the points are no longer there. So that's how we can actually bring these elements in. Now, the process of actually working with this, now I would go through and QA everything, but we can see if I go to the very end of the line here that this is still an accurate fit to the point cloud. Even though it was automatically done, we can still see that we have our accuracy maintained. And that covers pretty much all of the tools that we're going to go through inside of Edgewise. So at this point, now that I've created all these elements, I need to export them as well. So I'm going to do the exact same process. I'm just going to export to Revit, hit go, yes, and then inside of Revit, I'm going to repeat the process as well. So I'm going to go here, open model, and select the file that we just created. And then we'll be able to actually import those objects in. Edgewise does not change the coordinate system, so we just bring these elements in exactly where they're supposed to be, and then we can actually even bring the point cloud over top of it using an a RCP and or RCS file, and use those just like we normally would. And then so we have those elements in. And so with this, now I can change to a structural concept. There we go. And I can see that I can select these files. So these are native structural elements that we created inside of Edgewise and now have brought inside of Revit. So that's an example of our structure and our piping kind of coming together and working on a specific project. The only other thing I want to show really quickly is our ducting model, which is very similar to structure, and that we're going to create a kind of straight pieces and extract them. You have the same QA tools, and then we can actually make these flows. So it's a very quick process to do somewhat of a complicated duct run. This is something that would be pretty difficult to do inside of Revit natively. So with this, I'm going to extract this bottom piece, and I literally just need to draw a box around the bottom section, and that's it. I can adjust its height with this little arrow in the background, so that looks good. I'm going to go to the back and extract another piece. So it's a very simple, pretty quick process to just go through and extract these objects. If it's not quite the right size, which this one isn't quite the right size, but that's okay, we can fix that in a second. And then I'm going to do the top one. So I just want to get these pieces in here, and then once they're in, then I can QA them. So that looks pretty good. I'm going to select this one. As part of the QA process, this is going to look very familiar. We have a 3D view. I'm going to resize this element and make sure that we have the right size. So that looks better. And we can see all the fits are looking pretty good. So I'm going to go ahead and say those are fine. And so once this is set, then we can go through, we'll do some alignment stuff. But we can very quickly fill these in. So I'm just going to align these up. And so with this, the last thing I'm going to do is actually make connections. So between these two pieces, I'm just going to hit a radius elbow, and this is actually going to add a transition in for me automatically. So it's going to add this transition in. Now all I need to do is adjust it. And so within 20 seconds, I'm able to extract the top piece and actually create the elements that flow through this. So that's the top piece, and now I'm going to repeat the process for the bottom. And we can see that we've actually managed to extract this very nicely to represent this section. In 30 seconds, we're able to do that process. So we can see everything's fitted nicely, lined up properly, and represented accurately. And we can see that they're also still all connected as well. And so these are going to go into Revit the exact same way. So I'm going to go ahead and export this out to Revit and bring this into Revit as well. So it's, again, a very quick process, very accurate, and a very simple flow to actually how we create these. So I'm going to go ahead and do a new systems template and then import these in. So these are going to go in as native Revit objects and fill in that way. And it's, again, one click. That's all it is. So we just need to select the file, and those will come in the next 10 seconds or so, and they'll come in as native objects that are all connected properly inside of Revit. So those are all in. Take a quick look at them, and if I select a transition, I see it's a native transition. If I select an elbow, I see it's an elbow. So this has been brought in and they're all connected and shown here. So again, very quick process for getting these real-world objects out of a point cloud into native software like Revit. So the same process goes for AutoCAD or Plant 3D or any other software that we export out to. Depending on how much time I have, we can show the building and architectural side of things as well. So that's another option. Very quickly show those. But it's, again, kind of the whole idea is that we're going to be very quick in actually bringing these elements out of a point cloud and into the Revit or AutoCAD and just kind of moving as fast as possible, because the whole idea is to save as much time as possible. So I can show building here in a couple minutes, maybe 1 or 2. But at this point, I think I'm running out of time here, so it's probably more or less just to show the stuff that we have. At this point, I don't really have much more to show, but the idea for building is just to go through and bring the walls into Revit as built conditions. With that, I think I'll turn it over back to Mark here, and I don't have anything else to show for Edgewise. I really appreciate everyone's time, and thank you for stopping in.
Great. Thank you very much. Let's switch back on my presentation. All right, great. So I understand we've got some questions. Bree, can you let us know what questions we may have? Actually, I see she has sent me a link, so let me read off some of the questions I see here. This question is for GeoShack. Thad, about how long would it take to scan a typical hospital floor? I know this varies greatly based on project parameters. Just looking for a ballpark. Chad, are you there? I'll tell you what, we'll come back to that, everyone. I've worked with Chad long enough. I'll answer that best I can if he's not available. Can or are control points created in Recap? So that's a question for me. Control points are created inside of AutoCAD, Revit, and Navisworks. Using Autodesk point layout, I would place a point, and based on the existing coordinate system, those control points would have a coordinate associated with them. All right.
Hi, Mark. Can you hear me?
I can hear you.
Okay. Sorry about that. I can continue on with the questions.
Okay.
I have another one that came through. Will GeoShack and ClearEdge work together to provide me with a finished point cloud I can just import into my model?
Justin, you want to take that?
Yeah, so as far as the different export or import options for Edgewise, so the idea is that you can pretty much use any point cloud that's created from any software. So at GeoPoint, can make the process of actually going through the scans and kind of cleaning things up. Once they're imported into Edgewise, then we can go through and actually create the objects from the point cloud and then export it out. So it is a workflow that can work. We'll definitely be able to work with the two.
Great. And another question, can you filter and look for an object types in Edgewise? What about structural steel?
So we are not able to automatically extract structural elements like we are with piping. Specifically, the issue we run into currently is it's very difficult for software to tell the difference between, say, 2 pieces of angle iron and a T-joint or 2 pieces of C-channel and an I-beam. So with that process, because there are so many different specific shapes and standards for structure, we've gone through and have done what we've called object recognition. And so the idea is that we need to specify a little bit more information for the software and specify the standard we want to work with and the object type that we want to work with, and then and then we can go from there. As you can see, we saw with the pattern extract, we are able to automatically extract a pretty significant portion of elements But again, we just need to give it a little bit of information to get it, that extra little bit. We are always looking into, kind of improving our product, and so, there's always the thought process of trying to extract structural elements automatically. So that's something we're always hoping to get to at some point.
Great. Thank you, Justin. Another question, how accurate are Edgewise conversions?
I'm not 100% sure about what they're referring to with conversions.
After it says, can you demo some rectangular ductwork? So.
Okay. Yeah, as far as, so we can definitely, I can definitely show some of the more ducting stuff. Rectangular ductwork is something we have a specific tool for. So the whole idea is that we can extract the specific straight sections and then add transitions and elbows, and it's a very good product to get those kind of weirder shaped ducting that we can work with and get that into Revit or AutoCAD. So I'm not 100%, maybe transitions, is that ducting transitions? I'm not exactly sure what that's referring to, but that's kind of what we work with primarily. So that is something we do for sure.
Great. We'll follow up on these questions too following the webinar. Let's see a couple more questions. Are ClearEdge pipes and ducts true Revit families?
Great question. So they are actually native Revit objects. So those are true Revit, that we're basically using the Revit family objects for conduit, piping, and ducting. So those come in that way. So those are just like you created them inside of Revit, but we've brought them in and imported them and created them through the Edgewise import process. Structure is close. We actually can create new sizes for structure inside of the Revit family, but they're native family. You can treat them just like a regular family. And then with that process, there are a couple of things that we suggest as far as to get any sort of analytical information. We do suggest kind of doing a little bit of work on them, but they're not always. That's not very necessary a lot of times, and it's also a very easy process where we just say switch it over to this specific family from the original family we created. So because they are native Revit objects, so you treat them just like you would any other Revit object inside of, or any other Revit object.
Excellent. Another question. Do control points have coordinates to them? How do you set up coordinates for control points in Revit?
Okay, so all points do have coordinates associated with them, and part of the APL process in AutoCAD and Revit is to set up a coordinate system. The beauty with APL is you can set up different coordinate systems depending on the project. Some projects may have multiple coordinate systems. You may get a coordinate system from the surveyor, maybe a different coordinate system from maybe from the concrete company, and so you can show up on the job site and want to tie into either coordinate system. You can do that with APL. So it's a matter of setting up the coordinate system. Once that's set up in Revit with APL, then all the points have coordinates based off the coordinate system.
Great. Thank you, Mark.
Bree, I just got a text from Chad. Chad, are you on? Are you able to?
I'm on. I've been on. Yes, sir. Sorry about that, guys.
Yeah.
What was the other question? So how long it takes to scan the hospital floor? I don't know if we got around to answering that, but a typical setup for me to move and transition the scanner takes 5 minutes, and then generally we'll run like an 8-minute scan. So you're probably looking at 15 to 20 minutes per setup to actually capture that data. So just depending on if you wanted to go in every single room or if you could hit it down the main corridors, I would say give or take 6 to 8 hours probably.